Alright, so this video we are going to discuss statistics 1 paper for February March 2022. Okay, so let's have a look for question number 1. We are having a fair red spinner with this number and also the blue spinner with these numbers. Right, so each spinner is spun once and the number of the edge on which the spinner lands is noted. So the random variable x, okay, denote the sum of the resulting two numbers. Alright, so generally the x will be the sum for the two numbers that we get it from the red spinner and also the blue spinner. Okay, so first they want us to draw the probability distribution table for x. Okay, so there are many ways for us to get the probability distribution for the x. Right, so generally for me, because we can see that there's a two-dimensional result where we are having a red spinner and also a blue spinner, therefore we can try to consider using the possibility space diagram. Alright, so how will the possibility space diagram look like? It will look generally like this. We are having the red spinner and we are having the blue spinner. Okay, so for the red spinner, we are having 1, 2, 2, 3. So we list out the value 1, 2, 2, and 3. And for the blue spinner, we are having -3, -2, -1, and -1. Alright, okay, then we will try to fill in all the possible results here, okay, inside the cells. And all the cells here, we will focus on the sum, okay, for of the resulting two numbers. So as an example, for this particular cell here, all right, so it is actually we get a 1 for the red spinner and also -3 for the blue spinner. So the sum for these two numbers will be -3 plus 1, which is -2. Okay, so same thing happen for the second cell here. It will be -2 plus 1, which is -1. So we do the same thing for the rest of the cells in this table. -3 plus 2, you get a -1, and then 0, +1, +1. So the same thing happen here. All right, so generally after you complete the table, right, this is actually the possible outcome for the value of x that we have in this event, okay, in this situation. All right, so all these are the value of x that we have. So to form the probability distribution table for x, right, we actually need to also we need to list out the value for x. All these are the value of x. At the same time, we also need to figure out the probability for every single value of the x here. So for me, I will start with the smallest value. When x equals to -2, what is the probability here? Since the dice are fair, okay, for the spinner are fair, for both spinners are fair here. All right, so we just calculate how many times the -2 appear. So negative will appear once only in these blue color cells, all the blue color cells here. So it will be 1/16. All right, and after that, for x equals to -1, it appear 3 times. So it will be 3/16. All right, and then for x equals to 0, it appear, if you count, you can count from the number here, it appear for 5 times, it will be 5/16. Next value, it will be x equals to 1. So again, if I try to calculate how many times the x equals to 1 appear, so I will also have 5/16. And the last one, it will be x equals to 2. So for x equals to 2, when I try to count it, I will have 2 times, all right, for x equals to 2. Therefore, it will be 2/16. So once you list out all the value for the x already, then you can compile it into a probability distribution table. Okay, so we are having x, we are having the probability. So x, I'm having 5 different values here, which is -2, -1, 0, 1, and 2. And for the probability part, I just fill in. So it will be 1/16, 3/16, 5/16, 5/16, and also 2/16. So if let's say we want to double check and see whether our answer is still correct or not, you can just have a simple check where you try to add all the probability together and see whether is it equals to 1. If it is equals to 1, then very likely your answer will be correct. But if let's say you get the answer which is not equals to 1, that means 100% definitely your answer is wrong. All right, so this is a simple step for us to check on the value that we get, okay, for the probability part. All right, then now we go to part number B. Okay, so for part number B, they give us the value for the mean expected value is 0.25, and they want us to calculate the value for variance x. All right, so before we calculate the variance x, I will try to calculate the expected value for x squared first, ex squared. Okay, so to calculate the value for ex squared, you square the value of x, then you multiply it with the probability. So as example, -2, you square it, become -2 square, then multiply with 1/16. And you do the same thing for the rest of the value of x. So the next one will be -1, so it will be -1 square, multiply with 3/16, and so on. Okay, so when you try to simplify by using calculator, the value for ex squared will be 5/4. And now I want to proceed to the next step where I want to get the variance of x. So the general formula for variance x will be ex squared minus the mean square. So this is the formula that we are going to apply. Okay, so what is ex squared? You already calculated just now, which is 5/4 minus the mean. So the value for mean is given just now in the question, which is 0.25. All right, so you just substitute into your equation 0.25 square, and for the value of variance x, it should be 19/16. Or if you want, you can change it become decimal place, all right, which is 1.1875. Or you can change it become three significant figure, which is 1.19. So this is the answer for the variance x that we have. Okay, so now we are at question number 2. There's a certain in a certain country, the probability for more than 10 cm of rain on any particular day is 0.18, and independently of weather on any other day. So they want us to find the probability that in any randomly chosen 7-day period, more than 2 days have more than 10 cm of rain. All right, so for this question, if you have a look for the structure of the question, right, we are having a bigger number, which is 7 days, and out of the 7 days, right, more than 2 days, something happened to this more than 2 days. So generally for this structure, it is actually the binomial distribution. So we are talking about x. So x will be the number of days where the rain is more than 10 cm. Okay, so you have to focus and know that we are talking about x, which is the number of days that have more than 10 cm of rain. And it is actually a binomial distribution. All right, so originally you're having 7 days, and the probability for more than 10 cm of rain will be 0.18, which is given in the question here. Then for part number A, they want us to calculate the probability for more than 2 days. So that means the number of days will be more than 2. Okay, so to calculate the probability by using binomial distribution, x more than 2, that means you have to include the probability for 3, 4, 5, 6, 7, where to me, I think it is a bit longer. So what I will do is I will take 1 minus 0, 1, and 2. So 1 minus x equals to 0. So x equals 0 will be 7, C, 0, 0.18 power 0, 0.28, sorry, 82 power 7. Then minus the probability for x equals to 1, so 7c1, 0.18 power 1, 0.28 power 6. And also x equals to 2. Alright, so I will take 1 minus x equals to 0, x equals to 1, and x equals to 2. So the probability that I get will be equals to x greater than 2. Okay, so by just pressing the calculator, try to get an answer that I get, which is 0.115. Correct to 3 significant figure. Alright, then now we can proceed to part number B. Alright, so for part B, we are having 3 randomly chosen 7-day periods. Find the probability that exactly 2 of these periods have at least 1 day with more than 10 cm of rain. Alright, if you look at the structure of this question, it is a little bit complicated, where we are having 3 7-day periods, and we want to find out that exactly 2 of these periods. Okay, so again, please highlight the word periods. Just now in part number A, we are talking about number of days, and now we are talking about the number of periods. That means the variable actually is not x anymore. You can denote it by using some other letter, which is maybe y, right, to denote the periods. Okay, then we have at least 1 day with more than 10 cm of rain. So at least 1 day. So here we still have the day. Okay, all right. So you can see that this is actually a two-stage question for binomial distribution, where at first you need to find out the probability for at least 1 day with more than 10 cm of rain first, and after that only you find out the probability that exactly these 2 periods have this probability or have this situation. Okay, right. So let us start with at least 1 day with more than 10 cm of rain. So first, when we are talking about the number of days, it is still about the x. So for the binomial distribution just now, we are having this 7 and 0.18. At least 1 day means that x greater equals to 1. So I want to get this probability. I will take 1 minus x equals to 0. So 7 C0, 0.18 power 0, 0.82 power 7. If you try to simplify it, right, you will have 1 minus 0.82 power 7. And when you try to press calculator, the answer that I get should be 0.751, correct to 3 significant figure. Alright, so after we found the probability for at least 1 day with more than 10 cm of rain, now we come back to the focus here, where we are having 3 periods, and exactly 2 of these periods something happened. So again, for this structure, what you can see is it is still a binomial distribution. So I'm using y now. Just now the x is the number of days, and y I try to denote it as the number of periods of 7-day periods. Right, so when I'm having y, also binomial distribution, we are having 3 randomly chosen 7-day period here, so n equals to 3, and they want to calculate, or they are interested to find out that 2 of these periods have at least 1 day with more than 10 cm of rain. So that means the p here should be equal to 0.751, which is the probability that you calculate just now. And they want you to calculate the probability for y equals to 2. Okay, so we are having 3c2, then 0.751 power 2, and 1 minus 0.751 power 1. Okay, so please take note that when I try to press the calculator, right, for this step, the 0.751, actually I will press it in the original form, which is 1 minus 0.82 power 7, instead of this one, because this one we already cut short the answer. So this is not my final answer, right? So when I want to use the 751 as a step, okay, in the calculation, you should try to use back the original value here. Okay, so if you press calculator, then generally you will have 0. Original value will be 42147116115. And we try to cut it short into 3 significant figure, where I will have 0.421. Okay, so correct to 3 significant figure, and this is actually the answer, where 2 of the 3 periods are having at least 1 day with more than 10 cm of rain. Okay, so now we come to question number 3. There's a summer camp. At the summer camp, arithmetic test is taken by 250 children, and then the times, they are talking about the times taken, all right, to the nearest minute to complete the test were recorded. So the results are summarized in the table. So this is the table that we have. Okay, so first question, they want us to draw a histogram to represent this information. All right, so before you draw the histogram, if you double check and have a look for the width, okay, of all these class interval, you realize that they are different. So that means we are having unequal width histogram for this question. All right, so when we are having the unequal width, of course, we need to get some important values first before we can draw the histogram. So first of all, I want to get the class boundaries. All right, so for the class boundaries, if you double check, the upper limit and also the lower limit for the first and the second class, right, there's a gap. They are not the same value. Therefore, we have to make some adjustment to make it become class boundary, where it will become 1 minus 0.5, you get a 0.5, and 30, you plus 0.5, then you get 30.5. So for all the lower limit, for the class interval, you try to minus 0.5. And for the upper limit, you will add 0.5. All right, so eventually, these are all the class boundaries that you have. Okay, so after the class boundaries, we can use it to find out the width for every single class here. So to get a class width, it is 30.5 minus 0.5, where you get a 30. 45.5 minus 30.5, you get 15. And you do the same thing for the rest of the classes. Okay, so very obvious that you can see that from the width here, all the bars have different width. So we are going to draw the unequal width histogram. Right, so we are having frequency now. Frequency, you can just copy it from the table. And now when you want to draw unequal width histogram, the y-axis will be the frequency density. Frequency density. This is the y-axis that we need to draw. Okay, so for your information, the frequency density will be equals to frequency divided by width. So for the first frequency density here will be 21 divided by 30. So 21 divided by 30, I'll get the value 0.7. 30 divided by 5, I'll get a 2. And again, we do the same thing for the rest of the class. Alright, so once I have all the values that I need for a histogram, then I will start sketching it. For the x-axis, it will be the class boundaries or the time taken in minutes. So the smallest value is 0.5 until the largest value, which is 100.5. Okay, so according to, maybe refer to the graph paper that is provided in the answer booklet. For me, I will start from 0.5, where it will look something like this. Okay, so I will start to sketch it in this way. This is my y-axis, and I will have an x-axis here. Okay, so for me, I will start this point as 0.5. So I make a slash here. Right, so this one will be 20.5, 40.5, 60, 80, and also 100.5. And the x-axis label will be for time, and then it is in the unit of minutes. Okay, then for the y-axis here, the highest value should be 8.6. Therefore, I will make it like this: 2, 4, 6, and 8. And the label for the y-axis will be frequency density. Okay, so now I will start sketching the histogram. Okay, for the first bar, it is from 0.5 to 30.5, and the frequency density is 0.7. So 0.5 until 30.5, it will be somewhere here. 0.7 means it will be 3 small boxes are 3.5 of the small boxes, which is 0.7. Alright, so I'll try to sketch it in this way. Alright, then the next one will be 2, which is from 30.5 to 45.5. So 45.5 will be halfway between 40.5 and 50.5. So this is 45.5. And also the height should be 2, where I will have it until here. Okay, so maybe I can draw it more accurately on the line. Okay, then the next one, the height will be 3.4 and the width will be 45.5 until 65.5. So again, this is where we have for 65.5, and then the height should be 3.4, which is somewhere here. Alright, so this is the third bar that we have. Fourth bar, 65.5 to 75.5, and the height will be 8.6. So where is 75.5? It will be somewhere here also. And then 8.6. So 8.6 will be 3 bars above the 8. Alright. Okay, and okay, sorry, I drew the wrong line. So the line should be from here. Okay, then next class. So this is the fourth class already, and the fifth class will be from 75.5 to 100.5, and the height is 1.8. So the 1.8 will be here. Alright, so generally this is what we have for our histogram. Okay, so you can observe that the width of the bars are different. Okay, right, so now let's continue further. Okay, so for part B, they are asking what is the class interval that contains the median. Alright, so to get the class interval that contains the median, we might need a little bit of help from cumulative frequency. Okay, so for cumulative frequency, the first one that we have is 21. Then the cumulative frequency for the second interval will be 21 plus 30, so which is 51. Then plus 68 again, I will have 119. Then plus 86, I'll have 205. And if I add 45, I will get 250. When we are having 250, right, median means that the center position for the whole set of data. So the center of 250 will be 125. Okay, so we will need to look for the value or the data that's at the 125 position. So you can observe it from the cumulative frequency. For the first class, it accumulates until the frequency 21. Second class from 21 until 51. The third one from 51 until 119. And the fourth class is from 119 until 205. And you can see that from the value 125 is actually in this class, where the cumulative frequency will be from 119 until 205. And this will be your median class. Alright, the class interval for median. So we want to have a look for the original class interval, which is 66 to 75. Alright, so you can straight away write it out as 66 to 75. And this is the class interval that contains the median. Okay, and after that we will proceed to part number 3. So for part number 3, they tell us that the mean time, the estimation for mean time is 61.05, and they want us to state the feature of the distribution accounts for median and the mean being different. So when usually they ask for the distribution, right, maybe you can make some comment, or maybe can give some answer that is related to the shape of the data. All right, so for here, they actually focus on the value of mean, which is 61.05, and they want us to compare with the median. So the median value will be 66 to 75. If you compare these two values, very obvious that mean and variance, the value for mean and the value for median will be different. All right, so when mean and median are different, okay, what is the shape or what is the characteristic for a distribution for this set of data? So once you realize that mean and median are not having the same value, generally the distribution will not be symmetrical. Okay, so on the other hand, if let's say you are having the mean and also the median with the same value, that means the distribution will be symmetrical. So for our case here, they are not the same, therefore they are not symmetrical. Okay, for this whole set of data. Right, so this is how we solve question number. Okay, so question number 4. We are having the weight of male leopards, okay, in a particular region are normally distributed. So maybe this is the keyword, highlight the keyword normally distributed, okay, with the mean 55 kilogram and also the standard deviation 6. Okay, so find the probability that a randomly chosen male leopard from this region weighs between 46 and 62. Okay, so it is very obvious that this question belongs to normal distribution, where we are having the mean is 55 and also the standard deviation is 6. So when you want to write the symbol, right, the second parameter here should be a variance, so we should write out 6 squared. And they want us to calculate the probability that the male leopard, right, weight between 46 to 62. So that means the value of x should be between 46 until 62. Okay, so this is a normal distribution. Therefore, to calculate the probability, we need to standardize our x become z. So to standardize it, generally what we need to do is we have to minus the mean, where we take minus 55 divided by the standard deviation, that means divided by 6. Okay, for both the values here. Okay, so when I try to press the calculator, I'll have negative 1.5 for the first value. And for the second value here, I'll get a very long answer. So I will write it up to 3 decimal places. Okay, because for this part, we will use this value to find out the probability from the normal distribution table later. And for our normal distribution table, right, the value of z that they can accommodate is until 3 decimal place. Alright, so I will write until 3 decimal place. Okay, so to find this probability, I can take the area where z is smaller than 1.167 minus the probability that z is smaller than negative 1.5. Okay, what's the probability for z smaller than 1.167? So you look at the answer here, 1.167. You look at this, 1.16. So 1.16 we will get this value where it is equals to 0.8770. So 1.167. So you look for the 7 at the end. And you need to add 14 to the last 2 digits of the answer here. So if you take 14 plus 8770, you'll get 8784. So for this particular value, we have 0.8784. Okay, so minus, I just put a minus. I want to get a value for z smaller than negative 1.5. there's no negative 1.5 in our table, so we will just look at the value for 1.5. So for the value of 1.5, okay, so for the value of 1.5, what we can get is this answer, which is 0.9332. So 9332 is for the area where z smaller than 1.5, and now we're having z smaller than negative 1.5. If you try to understand it by using the area of the normal distribution, you need to take 1 minus 0.9332 to get the area for z smaller than negative 1.5. Okay, so from here, if you try to simplify all your answer, you will get 8116, or usually I will change it become 3 significant figure, which is 0.812. Right, so this is how we get the answer for part A in question number 4. So we proceed to part number B. Okay, so for part B, we have the weight of female leopards now. Okay, in the region, again, you can highlight the keyword normally distributed with this mean and also the standard deviation of sigma, where we don't know the sigma. It is known that 25% of the female leopards in the region weigh less than 36 kilogram. This sentence actually gives us important information where for me, I will use Y to denote the female leopard's weight. Okay, so it is normally distributed also, which is 42 with the sigma squared. Okay, so from this sentence, 25% of the female leopards weigh less than 36. So if I try to translate into a simple form, I'm having Y, which is the weight of the female leopards, less than 36 kilogram. The probability is equals to 0.25. Okay, and then the next step will be standardizing. You have to change the Y become Z. So how to change it become Z again? You have to minus the mean, which is 42, divided by standard deviation. And too bad we don't know what is the value for standard deviation, right? Okay, never mind. We just write a standard deviation and equals to 0.25. If I further simplify it, I will have negative 6 over sigma equals to 0.25. And I will want to denote my equation here by using a normal graph. So this is 0. 0.25 is a small area, and the symbol here is smaller than, and it means that my z value will be somewhere here. So that when z is smaller than this particular value, it is equals to 0.25, where this is a small area. Right? So now I want to find out from the normal distribution table, what is the exact value for the area 0.25? Okay, so if you have to look for the area part now, all these center part are the area. All the side value are value of z. So now we are having the area value lah. So the area value is 0.25. So we will try to look for 0.25 from the area value here, all the area here. You can see that the smallest value for the area will be 0.5 until 0.99, 9986. There's no area which is 0.25. Okay, so that means if you want to refer back, when the area does not exist in the normal table, right, you have to look for the matching area. So that means this is 0.25, the small area, where the matching area will be this whole thing, which is 0.75. So instead of looking for 0.25, right, we should look for 0.75, the area from the table. Okay, so I'm going to look for 0.75 here. If you want, you can have a look for 0.75 from the table itself. Look for a smaller number that is closest to the 0.75, where I think it should be this one, 0.7486. Okay, so if you read the value out to get the value of z, it will be 0.67. So to get 0.75, you need to add 14 at the last two digits here. So if you have a look, is there any 14 in our adding part? There's no 14, but we will just choose a number which is closest to 14. So I will select the 13 here, and the value will be 4, which means that if you look at the answer, it will be 0.674 for the value of z, 0.674. Okay, so we go back to our solution here. The value of z will be 0.674, but you have to decide whether is this a positive value or negative value from our graph. So our graph here, the z is on the left hand side of 0, right? So that means the value of z should be equals to a negative value. So it should be negative 0.674. And to find out the sigma, you should substitute this value z, negative 6 over sigma, will be equals to negative 0.674, and therefore you can get the sigma, which is 6 divided by 0.674, and the sigma will be equals to 8.90, correct to 3 significant figure. Okay, so this is how we solve for the sigma. And then we have a extra explanation on this one for negative 0.674. Just now we have a look for the area, which is 0.75, to get the value 0.674, right? Okay, so we get the 0.75 from the area, from this area, all right? Okay, and if let's say you are aware, if you scroll down to the bottom part of this table, there's a simple table at the bottom, and the simple table here actually will provide us some useful information as well, or you can cut short the time to find out the value of z. So you can see that when my area is 0.75, the z is 0.674, which is exactly the same like what we find out from the value on top. So if you are using this table, it will actually cut short our time, okay, to find out the value of z. Okay, so you can consider to use this table if let's say the area that you want to find out is included in this table. Alright, so this is what we have for question number 4, part B, and our answer should be 8.9 for the sigma. Okay, so we'll proceed to part number C. For part number C, the distribution of the weight of female and male leopards are independent of each other. So highlight the word independent. That means when you want to calculate the probability for this one, right, you can separate them. You can calculate it separately. So a male leopard and female leopard are each chosen at random. So I'll have one female leopard and also one male leopard. Okay, so they want us to find the probability that both the weight are less than 46. Okay, so since these two weight, male leopard weight and also the female leopard weights are independent, so when you want to calculate the probability, you can multiply them straight away. Where I'm having the male leopard weight is smaller than 46. At the same time, the female weight also smaller than 46. Okay, so this is how we should calculate out the probability. And again, to calculate the probability for x and also the y, both of them are normally distributed. Therefore, we have to standardize it by minus the mean. So the mean for male will be 55 divided by standard deviation of the male leopard, which is 6. Okay, so multiply with the female one. So 46 minus the mean, which is minus 42, divided by standard deviation. So for our standard deviation here, we actually have to use back the original value for standard deviation in this part. Okay, so just now if I try to keep the long value, it should be 8.9020771151. Okay, so when I press calculator, I'm trying to press and keep the original long value. Okay, and then I'm having z smaller than negative 1.5 multiply with z smaller than 0.449. So again, you can see that I'm trying to keep until 3 decimal places for the value of z. If I want to use it to find out the normal distribution table to get the probability. Okay, so for the value z smaller than negative 1.5, we actually get the value earlier in part number 1. For the male tiger, right? Sorry, male leopard, for the probability of z smaller than negative 1.5, the answer is 1 minus 0.9332. So I will use it in our calculation here straight away, where I'm having 1 minus 0.9332 multiply with the probability for the female leopard. So z smaller than 0.449. So I will go to the table again, look for the value of z 0.449. Okay, where is 0.4? This one, 449, right? Okay, so let's have a look what is the value that we get here. 0.44, which is 6700, and then 9. So the 9 here is 32. That means you have to take 6700 plus 32, and you'll get 6732, right? Okay, so we will put in as 0.6732. Okay, so we will multiply them together, and you'll get a long value again. And of course, I want to cut it short into 3 significant figures, where it will become 0.0450. Okay, so this is how we solve this part number C for question number 4. Okay, so we are at question number 5. We have a group of 12 people that consists of 3 boys, 4 girls, and 5 adults. Okay, so first part, they want us to form a team of 5 people can be chosen from the group. Okay, so highlight the keyword chosen. So that means later we are using the combination method to calculate the number of ways, right? So chosen from the group if exactly 1 adult is included. So only 1 adult is included. That means from the 5 adult, I want to choose only 1 of them. Multiply with the rest. So the rest will be, we don't want to consider anymore whether they are girls or boys. So you combine all this together, where you're having 7. And from these 7 people, I want to choose 4, so that I can make a group with 5 people. All right, so it will be 5C1 multiply with 7C4, and you get 175. Okay, part B. In how many ways can a team of 5 people be chosen? So again, highlight the word chosen. So this also gives us a hint that it is about the combination. Right, so from the group, if the team included at least 2 boys and at least 1 girl. So this is the restrictions that they give us. We must have at least 2 boys in the group and also at least 1 girl in the group, in the team. Okay, so for this kind of question, it will be good if you can list out all the possible cases. So we're having boy, girl, and adult. So the first basic restriction that give us is at least 2 boys. So let's say we are having 2 boys, 1 girl, so we can have 2 adults. So this is the first case that we have. We might also have 3 boys, 1 girl with 1 adult. Also fulfill the restriction that they give us at this question. Okay, so is it possible for us to have 4 boys in the group? It is impossible because maximum we are only having 3 boys only. Alright, So you won't able to have 4 boys. Okay, so how about 3 boys with 2 girls and 0 adult? This is also one of the cases where we still fulfill the restriction here, at least 2 boys and at least 1 girl. Okay, so besides all the cases here, we consider back maybe to increase the number of girls. Okay, so again, if let's say I'm having 2 boys, then I might have 2 girls, then I will have 1 adult. Or another case is 2 boys with 3 girls and 0 adult. Okay, so I think this is all the possible cases that we have okay, for the calculation or description for this question. Right, so now we will start the detail for the solution. Okay, 2 boys, 1 girl, and 2 adults. So 2 boys means 3C2. From 3 boys, you want to choose 2 out. Okay, for girls, it will be 4C1. From the 4 girls, you want to choose 1 girl out to form the team. And also for the adult, it will be 5C2. Right, and I'm having 120 for the first case. Second case, we do the same thing. 3 boys, you want to choose all the 3. 4 girls, you want to choose 1 only. And also 5 adults, you want to choose only 1, which is 20. Okay, so third case. All the 3 boys are included, so it will be 3C3. Multiply with 2 girls are included, 4C2, 0 adults, so 5C0. For this case, you should be able to get value 6. So you can do the same thing for the rest. So 2 boys, 3C2, 4 girls, 4C2, and 1 adult, 5C1. Answer is 90. And the last case here, it will be 3 boys. 3 boys want to choose 2, 3C2. 4 girls want to choose 3, 4C3, and also 5C0. And now for this part, you will have 12. Alright, so once you find out all the cases already and also all the combination for the different cases, so to get the final answer, you total all of them out. If you get a total, you will get the answer, which is 248. This is how we solve part number B. Alright, then now we continue to part C. Okay, so for part C, this group, the same group of 12 people stand in the line. And then they are asking for how many different arrangements. So maybe for this question, you can highlight the word arrangement. So this is the keyword to tell us that later we are going to arrange that, which is permutation. So for permutation, your steps will definitely involve P, NPR, or maybe the factorial. Okay, so what is the restriction here? The 3 boys stand together and the adult is at each end of the line or in the line. Okay, so when you have adults at each end, that means the first one is adult, okay, the last one is also adult. So in the center here, we actually have 10 more people, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, alright, so now first we should try to arrange the adult first. We are having 5 adults in total, but you want to place 2 adults at each end. So that means to arrange 2 adults at each end from the 5 adults, the step will be 5B2. Okay, so once I place the adults already at the end, so now I want to consider all the arrangement in the center of the line. We are having boys, but these 3 boys must stand together. So that means I will treat them as one unit. Okay, and we have 4 girls, 1, 2, 3, 4. We have remaining 3 adults. And now I want to arrange all the people here. So you can see how many units do we have. We have 1 unit here, 1, 2, 3, 4, 5, 6, 7, 8. We are arranging 8 people. So that means 8 factorial. And after that, you also need to consider the arrangement inside the group of the boys. So multiply with 3 factorial. There are 3 boys inside, right? So to arrange all the 3 boys, you are having 3 factorial way to arrange them. So when you multiply all these together, you'll get 4838400. Okay, so this is the answer for our question number 5, part C. Okay, so the last question for this paper. There's a factory produced the chocolate in 3 flavors. We are having lemon, orange, and strawberry in this ratio. So 3 to 5 to 7 respectively. So now checks the chocolate on the production line by choosing chocolates randomly one at a time. Okay, first question, find the probability that the first chocolate with lemon flavor that now choose is the 7th chocolate. So that means the number of chocolate that he inspects for the lemon flavor, right? Okay, is up to and until the 7th chocolate that she checks. So generally for this kind of question, it should be a geometric distribution. And for the geometric distribution, you need to consider the probability of getting a lemon flavor chocolate. So what is the probability for lemon flavor chocolate? So the P should be equals to, for lemon flavor, it will be 3 in the ratio 3 out of the total, which is 15. So the ratio for the lemon will be 3 over 15, or you can rewrite as 1 over 5. Okay, so the number of chocolate that she checks is the 7th chocolate, which means that they want us to calculate the probability when the number of chocolates inspected is equals to 7. Okay, so that means what? That means the first 6 chocolates are not the lemon flavor. The 7th chocolate is the lemon flavor. So for the first 6 chocolates that is not lemon flavor, it will be Q, which is 4 over 5. P is 1 over 5, right? The lemon flavor is 1 over 5. So for non-lemon flavor will be 4 over 5. And the first 6 chocolate are all non-lemon flavor, which is 4 over 5 power 6. And the last one, which is the 7th chocolate, will be the lemon flavor, which is 1 over 5. So from here, to get the probability, it should be equals to 0.0524. Correct to 3 significant figure. So this is what we have for part number 1. Part 2. Find the probability that the first chocolate with lemon flavor that Nell chooses is after she has checked at least 6 chocolates. So for this question, generally, the first chocolate with lemon flavor appear, okay, after she checked at least the 6 chocolates. So that means the very first lemon flavor can be at x equals to 7, okay, at least 6 chocolate. So the after the 6 chocolates, the first lemon flavor will be at the 7 chocolate, and also the next term. So that means it can be at least 6 chocolates, it can be at least 7, it can be 7 chocolates also, right? So if let's say 7 chocolate, that means the lemon will be the 8th flavor. If let's say she inspected and get the lemon flavor after the 8 chocolates, that means the lemon flavor will be at the 9. Okay, so for this question, generally the probability that they want us to calculate is actually the number of chocolate that she inspect is at least, that means greater or equals to 7. Okay, so which means that the first 6 chocolates that she inspect is not the lemon, the 7 only is lemon. So it should be x greater equals to 7. That means the total number of checking the chocolate, right? It should be, the least value will be 7 or more. Okay, so how to find the probability for x greater equals to 7? In a geometric distribution, we can't find out the probability straight away because it has unlimited value of x. Therefore, you should take 1 minus x smaller equals to 6. Okay, and there's a formula, a shortcut formula for x smaller equals to r. When we are having x smaller equals to r in the geometric distribution, right? The probability is actually 1 minus q power r. So we are going to apply this formula in our calculation here. Since we are having x smaller equals to 6, therefore I will have 1 minus q. Q will be 4 over 5 power r. R is the 6 in our case here. Okay, generally you should get 0.262144, and of course I want to change it become 3 significant figure, which is 0.262. So this is how we solve part B. Okay, so proceed further to part C. Okay, for part C, we are having surprise boxes. So for surprise boxes, right, we are having the chocolates in this way: 3 lemon, 5 orange, and also 7 strawberry. So total there are 15. So we have Petra has a box of surprise chocolate. She choose 3 chocolates at random from the box. Okay, so from here you see the keyword choose. So again, choose is actually the keyword for combination. That means later you very likely will use NCR to get an answer when they want us to find the probability or when they want us to find out the number of ways. Okay, so I want to choose 3 chocolates at random from the box. She eats each chocolate before choosing the next one. So this sentence tells us that this is a without replacement case. Okay, because after she chooses 1 chocolate, she will eat. So all the situation here will be the without replacement case. Okay, part C, find the probability that none of Petra's 3 chocolates has orange flavor. There's no orange flavor in the selection. So to calculate the probability, I will separate my step into orange and non-orange. So there are 5 orange in total, and I select none of them. Therefore, it should be 5C0. Multiply with the rest, lemon and strawberry total, there are 10. So I want to choose 3 from this flavor, it will be 10C3, and divided by the selection without restriction. So in total, I'm having 15 chocolates regardless to the flavor, and I want to choose 3 of them. So it should be 5C0 multiplied with 10C3 divided by 15C3. So for this question, if you try to get the answer, it should be equals to 3 over 13. And this is how we solve it. Okay, then part number 4, part D. Sorry, I think I make an error here. For part number C, the answer shouldn't be 3 over 13. The answer here should be 24 over 91. If you try to press the calculator correctly, it should be equals to 24 over 31. 91. Okay, then only we proceed to part number 4, part D. They want us to find the probability that each of Petra's 3 chocolate has different flavor. So that means to calculate the probability, now I want to separate my group into 3 different groups. So the first group is lemon. So for lemon group, right, 3 lemons, I want to choose 1. Okay, then 5 orange, I want to choose 1 as well because each of the chocolate have different flavor. So for strawberry, it will be 7C1 divided by the total selection without restrictions. So total I'm having 15 chocolates and I want to choose 3 of them. So for this question, only the answer is 3 over 13. Okay, then how about we go to question number 5. part E. Question number 6, part E, sorry. Okay, so for this question, find the probability that at least 2 of Petra's chocolate have strawberry flavor, given that, so highlight the word given that. This is an important keyword that tells us that this is actually the conditional probability. Okay, so we are having the conditional for probability for this case. When you write out the symbol, you have a slash here. Given that none of them has orange flavor, so that means this one is no orange. I already know that no orange flavor is selected. I want to calculate the probability that we are having at least 2 strawberry. This is the symbol for conditional probability. I want to expand it into the conditional probability formula where we are having 2 strawberries intersect with no orange. Sorry, no orange divided by the probability of not having orange in the selection. Okay, sorry again here. Okay, so now we have to consider what are the possible cases for at least 2 strawberries intersect no orange. Okay, so for the first case that we have, we might have two strawberries with 1 lemon. If we are having 2 strawberries, right, then it will be 7C2 multiply with 1 lemon. So 1 lemon will be 3C1 divided by 15C2. So if you want to make it clear, this is the case where we are having 2 strawberry with 1 lemon. Okay, so this result fulfill what you have on top here. So besides this result, we have some other result where we can have 3 strawberry. That means also no orange and no lemon. So 3 strawberry will be 7C3 divided by 15C2. And for this part, the probability is equals to 3 strawberries. When you're having all the 3 strawberries, means that it fulfill the condition here, at least 2 strawberry and also no orange. So this is another case. Okay, so this is a probability for the numerator, and you divide the answer on top by denominator where the probability is not having orange. So the probability of not having orange, we already get it just now in part number C, which is 24 over 91. And I can straight away substitute it in our denominator here, 24 over 91. And if you try to simplify the answer from this part, you should able to get 49 over 60. Or you can change it become 3 significant figure, which is 0.817. Okay, so this is a discussion for this February March 2022 paper 5.2. Thank you for watching this video.